All right, let's jump straight into this explainer on Puma Punku. We're going to objectively explore two completely different scientific explanations for how one of the absolute most enigmatic ancient sites in the world was actually built. For decades, the sheer precision of these ruins has sparked some pretty wild theories. But today we're going to stick purely to the hard, documented evidence from the source material to try and understand the real engineering mystery here. So the big question, were these massive, impossibly precise stones carved by hand, or were they actually cast using a lost ancient chemistry?
Just picture trying to carve a perfectly crisp, 90-degree interior corner into solid, unforgiving rock using nothing but a copper chisel. Well, modern researchers from UC Berkeley actually tried to do exactly that. They attempted to recreate this very stonework using the exact stone and copper tools we know the ancient Tiwanakans possessed. And you know what? Their efforts were entirely inconclusive. They found that standard copper and bronze tools were basically useless on this specific type of rock. It literally forced them to conclude that the builders must have had access to techniques that are just completely unknown to us today.
To truly wrap our heads around the magnitude of this mystery, we have to grasp the sheer scale of the site itself. We're talking about a sprawling megalithic complex situated in the Bolivian Andes, sitting at a breathtakingly high 3,850 meters above sea level near Lake Titicaca. The site is covered in giant red sandstone terraces and scattered blocks that have kept researchers and engineers scratching their heads for over a century. In fact, when the Spanish colonial chroniclers first arrived, they found it already in ruins, and the local populations honestly had absolutely no idea who had built it.
Now, the undisputed stars of Puma Punku are the famous H blocks. These things are made of volcanic andesite. For context, that is an incredibly hard rock. It rates about a 6 to 7 on the Mohs hardness scale, putting it right up there near quartz. Yet, field surveys confirm they exhibit sub-millimeter joint tolerances and perfectly flat right interior angles. It's actually kind of wild. When researchers 3D printed these blocks and reassembled them, they discovered a level of flawless fit that pre-Columbian Andean masonry was simply not supposed to be capable of.
Okay, but before we get too deep into the weeds with these anomalies, we really need to set the record straight on the timeline. Let's just go ahead and toss out that popular 15,000 BCE myth you might have heard. That date comes from an early 20th century researcher named Arthur Pisnansky, who used an astronomical alignment method that has completely collapsed under modern scientific scrutiny. Sure, it was popularized by 1960s pop culture and still bounces around the internet today, but to stay grounded in actual facts, we have to look at the radiocarbon dating of the site's organic inclusions. That hard data firmly anchors the monumental construction of Puma Punku to between 536 and 600 CE. So, moving on to the logistics. The really crucial point here is the staggering mass of these materials. The largest red sandstone block at the site weighs an estimated 131 metric tons. Just pause and let that sink in for a second. 131 tons. At nearly 4,000 meters elevation, without draft animals like oxen, and literally without the invention of the wheel, trying to move a mass of that size overland is an absolute logistical nightmare. We know moving a single 100-ton block overland requires thousands of men pulling in perfect unison. So let's contrast the two primary hypotheses for how the smaller, but still massive, andesite blocks made their way across Lake Titicaca. The mainstream archaeological theory suggests these solid stones were floated on giant Totora reed boats. Now, that's incredibly dangerous, but historically plausible for smaller stones. On the flip side, the geopolymer hypothesis suggests a completely different, honestly brilliant approach. Don't move the solid rock at all. Instead, just safely move volcanic sand in easily manageable baskets and then chemically bind it into solid stone right at the construction site.
Think about the geometry for a second. The andesite slabs feature complex re-entrant cuts, which are essentially sharp, inward-facing interior corners. If you're a stonemason relying on a hammer and a chisel, carving perfectly flat interior corners into hard volcanic rock is your worst nightmare. Literally one tiny slip and the entire block is ruined forever. But if you are pouring a wet slurry into a carefully constructed wooden or clay mold, well, those exact same complicated interior cuts become incredibly trivial to produce.
Mainstream archaeology actually fully accepts that Puma Punku utilized a modular system. These blocks were meticulously designed to perfectly interlock, kind of like a giant master kit. They didn't use any mortar. The structural load of the building was distributed through pure fit alone. The cuts on adjacent faces were meant to receive matching protrusions. And the mind-bending part? These identical cuts repeat across blocks that would have been quarried and worked weeks or even months apart. That implies a highly centralized design plan and just an astonishing level of quality control.
Then there are the boreholes. There are nearly 900 perfectly cylindrical boreholes across the site. They're uniformly 4 millimeters in diameter with flat bottoms, and they're spaced with unbelievable regularity. Mainstream science attributes this to patient abrasive bow drilling. That's a technique where a worker spins a stick with sand and water to slowly, agonizingly grind out a hole over many hours. However, the geopolymer view suggests a wildly faster, more elegant method. What if they simply press wooden dowels or copper tubes into wet, unhardened cement before it cured? And the engineering doesn't stop at the stone. To lock these blocks together, the builders used metal clamps. But they didn't just hammer pre-made metal shapes into the grooves. No, they poured molten copper, arsenic, nickel, bronze directly into the carved channels. This was a cast-in-place technique. Remember, at this dizzying altitude, oxygen is incredibly scarce. So to pull this off, they had to use portable, forced draft kilns right next to the stones just to reach the over 1,000 degrees Celsius needed to melt that metal. The metallurgy and the masonry were brilliantly integrated into one single system.
So, since modern tools can't easily replicate these precise cuts, let's officially introduce that peer-reviewed twist from material scientist Joseph Davidovits, the geopolymer or cast stone hypothesis. What exactly is a geopolymer? Basically, it's an ancient synthetic stone. Think of it like a highly advanced ancient concrete. It's made by combining ground volcanic rock or sand with a liquid alkaline binder, which is derived from local organic ash and minerals.
When we put these two views head-to-head, the contrast is really stark. The mainstream view demands immense, generational patience, theorizing that natural volcanic rock was chiseled and ground down with bronze tools and sand abrasives over decades. Pitted right against this is the highly compelling geopolymer hypothesis, arguing that a slurry of volcanic sand and organic binders was simply poured into precisely measured molds to cast the blocks right on site.
The absolute beauty of the cast stone hypothesis is how elegantly it solves the submillimeter precision problem. Think about it. If you use identical molds, you inherently produce identical, perfectly mating blocks every single time. The precision doesn't come from the incredibly steady hand of a master carver, it actually comes from the dimensional stability of the mold itself. That would easily explain how they maintained such flawless orthogonal reference geometry across entire massive fabrication runs.
Now for the actual scientific evidence backing this up, and it is staggering. In 2019, researchers put samples of Puma Punku andesite under powerful scanning electron microscopes. What they found was essentially a smoking gun. Organic carbon trapped right inside the rock's matrix. Why does that matter? Because natural volcanic andesite forms in magma chambers at over 1,000 degrees Celsius. Any organic matter should have been completely vaporized. Finding organic carbon inside the stone strongly hints that it was mixed at room temperature.
There are also specific patches on the stone that are incredibly revealing. Normally, if you chip a solid block of carved rock, you have to grind the whole surface down to fix it. But here, there are specific areas that look exactly like modern concrete repairs. It looks precisely like a repair made while a geopolymer mix was still in a semi-set plastic state. It's like someone came back with a trowel of wet mix to seamlessly bond new wet material to the already hardened stone.
If you accept the geopolymer theory, it completely reshapes our understanding of their logistics. Instead of risking the lives of their workers by attempting to balance unwieldy 20-ton solid stone megaliths on floating reed boats, the transport process becomes vastly more sensible. They were simply ferrying manageable, completely safe loads of volcanic andesite sand from the Surokapia volcano right across Lake Titicaca to the shores near Puma Punku, where it was then mixed and poured. It just makes so much more sense.
You know, the freezing Andean climate actually works heavily in favor of this theory too. At an average of just 8 degrees Celsius, the cold would give a geopolymer mixture a very long pot life or setting time. The slurry wouldn't just dry instantly, it would rain plastic for days, giving the ancient artisans plenty of time to shape the intricate details, press in the dowels for the boreholes, and perfect the finish before the stone finally cured to its quartz-like hardness.
Now, to be completely fair and strictly objective, we absolutely must highlight mainstream archaeology's valid objections to the geopolymer theory. First off, geologists note that a surface lava flow theoretically could pick up organic carbon from soil or plants as it advances, thereby preserving it inside the rock. Secondly, and probably more importantly, no industrial cement-making kilns or infrastructure have been found in the excavation records at Tiwanaku yet. And finally, no one has successfully replicated the exact chemical binder using only the ancient materials available in that specific region. Ultimately, the mystery absolutely still stands.
Whether Puma Punku was carved with an impossible, almost superhuman patience we can barely fathom today, or cast with a highly advanced chemical knowledge that has been entirely lost to history, it proves that a phenomenally advanced human engineering culture existed in the ancient Andes. And it begs a final, pretty mind-bending question for us to ponder. If the builders of Puma Punku could actually cast solid stone, what other ancient megalithic marvels around the world were poured rather than carved? Something to think about.